This is me. I'm making a video that's going to take us through the last three questions that I didn't get a chance to review in class. So this is question number 8. It says, write the following set in set builder notation. So I just need to remind you what set builder notation looks like, all right? As always, just like in the last video I made on set builder notation, we start with a brace. Then we talk about all values of x such that. Now we look at these numbers. You're going to be given a set of numbers that looks like this. 4, 5, 6, 7. Nothing in between, just those whole numbers, okay? So we're talking about everything greater than and including 4. So greater than and equal to 4, right? There's our inequality that we're going to write. And what types of numbers are these? These are those whole counting numbers, and we don't have a 0 here, so instead of using whole numbers, we're going to call them an element of natural numbers, okay? And as always, after we talk about what types of numbers they fit into, we close it with another brace. All right, so just reiterating, we start with x such that x is greater than or equal to 4, because it's 4 and counting onward. That's what these ellipses means. And then x is an element of natural numbers. Okay, we haven't done that for a while, so I wanted to repeat what it really should look like. All right, so that's that. So I'm going to move on to the next thing. There's a graph. All right, here we go. It says, what is the domain and range of this function? So let me grab another color here. Let's use yellow. So the domain, and we're going to use interval notation with this, okay? So the domain is, I got to give you a value, huh? We'll call this 7, or -7, pardon me, -7 on the number line, okay, on the x-axis. We'll call this way up here, we'll call this 6. All right, and just for fun, I'll just leave a mark there. I don't need a number there. You'll see soon that it's irrelevant. Okay, so as we sweep across along the x-axis going from left to right, the first value on the x-axis where I get an output, where there's a piece of a function, as we sweep all the way across, we are always sweeping across a function, whether it be up here, whether it be here in the middle, or whether it be down here. So it starts from the left at -7. And the reason I put a bracket around it is because of this closed circle. If this had been an open circle like this, I would have put parentheses around it. And as I continue across, this guy has an arrow here and it's going at an angle. So I can go on infinitely and come out with a value. So I can go on infinitely. Okay, since there's an arrow on the end of it. I cannot put a bracket around infinity because it's not an actual value. It's just telling me that it goes on forever. So let's use the same idea and talk about range. Again, we go from negative to positive. We go from low to high, right? As we went from left to right, we're going to go from low to high. So As we start way down here, this one is continuing way down there. So if we thought about it, this would go way down here. So infinitely. So we start at negative infinity. Right? There's a y value down there at negative infinity. And then as we sweep upward, where do we see the last bit, the last part of the function? And it stops at 6. Is it a closed circle or an open circle up here? Again, it's a closed circle. So we're going to put a bracket around the 6. And we did this in class, but this is me reminding you. And it's so similar on the test itself. Okay? That's great. So now we've completed number 9. This is the very last idea on the test. And it just so happens that this is the very last idea we had in class. This is what you did your homework on last night. So let me go ahead and do this. This is the hardest one, right? This is the most labor intensive, right? So let me go ahead and, oh, I'm not on that layer. So here we go. Let me just write this out. Let me go ahead and, whoa, that was horrible. Let me use this line guy. Let me just go ahead and do this. There it is. I'll get rid of that. We'll start writing again. So what's the easy part? I'll put my B down there. B is this color, 5 minus A is this color, 3. So we're looking for the rate of change of this function between the interval, on the interval 3 to 5, right? So B minus A, that's my denominator. Then I input my 5 into this function, find out what the answer is, and then subtract what I get when I put 3 in. So, shoot. Let me do this. It's going to be f of 5 minus, use that color, f of 3. Okay? Now, I'll put a new line in there, and I'll do it down here. I'll do all that math down here. So give me lots and lots and lots of room to write. Okay, so we know that 5 minus 3 equals 2. So that's done. Let's do f of 5. And what that means is everywhere you see an x up here, we'll put in a 5. So 5 squared minus 8 times that 5, because there's an x again, plus 3. And let me close that with big parentheses. Then we're going to subtract from that f of 3. So I'm going to write that one out. And that is, big parentheses, 3 squared minus 8 times 3 plus 3. Sorry about too many 3's. And then big parentheses. All right, well, let's do this math. Right? So let's go ahead and do this math. I'll write it right above it. 5 squared is 25. Minus 8 times 5, which is 40, plus 3. All right, well, 25 minus 40 is negative 15. Negative 15 plus 3 is negative 12. Did I get that right? 25 minus 40, that's negative 15. Plus 3 is negative 12. So I have negative 12. Negative 12. We're going to subtract from that. I'll start doing this math. 3 squared is 9 minus 8 times 3 is 24 plus 3. So 24 plus 3 is 27 sorry. Oof. I almost made a mistake. 9 minus 24 is 15. 9 minus 4 is negative 15. Negative 15 plus 3 is negative 12. OMG. This just worked out this way. Oh no. 9 minus 24 is negative 15 plus 3 is negative 12. Oh no. Negative 12. Oh, crud. All right, well, we have an answer. It won't be like this on the test, but here we go. Serves me right for making something up. Negative 12 minus another negative 12. Minus a negative is plus a positive. That's 0. If I have negative $12 and I undo that negative $12, I got 0. So 0 over 2, which is 0. So guess what I just found here? I just found a critical number, but that's okay. The slope here is 0. Right? The rate of change is 0 at that specific point. That is funny. So what it looks like is that we have a parabola that looks like this, and between here and here, I found 2 spots that were directly across from each other. So in between there, 4 must be our axis of symmetry. How dumb is that? Anyway, that's how you do this math. You're good to go. Oh, we'll go back. Any questions, let me know. Send me a message tonight. No big deal. And we'll get through this. I'm going to try and make this as easy as possible. Take care, guys.